Now we're going to be taking a look individually at each of the three steps in this pathway to harvest energy from molecules like glucose. Step one is glycolysis. The word glycolysis literally translates to the splitting of a sugar, glyco referring to sugar, and the word lyse meaning to split. And again, we're going to start this using a molecule of glucose. Now, through this process, one of the suggestions I have for you is to keep track of all of the carbons. Remember that glucose is a 6-carbon sugar. And so as we catabolize or oxidize the glucose, these carbons are going to be split apart and of course will be converted into carbon dioxide. So keep track of where the 6 carbons are at each step along the way. Now, glycolysis occurs in the cytoplasm. And if we look, there are 2 phases of glycolysis. The first is the energy investment phase. That's going to require 2 ATPs. So we're going to spend a little bit of energy to harvest a little bit of energy, if you will. Now, during this energy investment phase, the glucose is actually going to be split, and then this oxidation process will begin. The second phase of glycolysis is the energy payoff phase. Now, the energy payoff phase will produce 4 ATPs. And so if you think about this, if we put 2 ATPs in, we're going to get 4 ATPs out. That's a net gain of 2 ATPs, as we'll see in just a moment. But in addition, this energy payoff phase also reduces 2 molecules of NAD to form NADH. Now remember, this nicotinamide adenine dinucleotide in its reduced form has gained these electrons, right? And so these are our energy or electron carrier molecules. Now the final product of our energy payoff phase, since we've split our glucose in half, is going to be 2 molecules of a 3-carbon acid called pyruvate. Now let's look at this diagrammatically and remember that glycolysis is going to occur out here, out in the cytoplasm, outside of the mitochondria. And so here we see our 6-carbon glucose. Now remember that the glucose sugar occurs in a ring, but we're just illustrating it here with these 6 balls representing the 6 carbon atoms. And so during our energy investment phase, we're going to take 2 ATPs and pull the phosphates off of them. The phosphorylation of this 6-carbon sugar by adding the phosphate on either end primes this molecule to be cleaved or to be split in half. And once this 6-carbon sugar with these phosphates has been split in half, we end up with these 3-carbon sugar phosphate units. Each one of these is going to be converted into a 3-carbon pyruvate. And as you can see, this takes these electrons and adds them to NADH. And in addition, this catabolism liberates some free energy that we will use to make 1, 2, 3, 4 ATPs. So to summarize, 1 molecule of glucose that proceeds through glycolysis produces a net gain of 2 ATPs, but just remember we made a total of 4. We have 2 NADH electron or energy carrier molecules and 2 molecules of pyruvate. Now, remember that each molecule of pyruvate is a 3-carbon molecule, so we have 2 3-carbon molecules to keep up with our 6 carbons. Now, you didn't see in any portion of glycolysis the requirement for oxygen. So glycolysis does not require oxygen. And remember that it also occurs in the cytoplasm of the cell.